So this one is
All right, so we just saw about combining like terms, but before we can get to the next part, because those last ones were really too easy. They were just too easy. And don't give me that look like, but I like the easy.
What you call easy, we might not try easy.
Amen to that.
What I call easy, you call hard. Easy. Okay, it didn't work out, so I guess you're not my holla back girl. All right, so what if I had this? You can't see this? It's right there. I even used a black marker on a white piece of paper. All right, 7 square roots of 50. Can I do anything with this?
50 squared is
50 squared is 2,500, but I don't care about squaring 50. I want the square root of 50. Oh, in goodness. Now, what I can do here is I can break this down using multiplication. Don't even tell me 49 is the largest square that goes in. No.
It doesn't matter, huh?
It doesn't go in evenly.
25 times 2.
So now that's how I'm going to roll. 25 times 2. Now, why is that cool?
Because 25 is a perfect square.
You got that right. 25 is a perfect square. What is it the square of? And what am I going to do with that?
Add the 5 to the 7.
Add the 5.
Multiply 5.
The door's open.
Oh, yeah.
You're about to become an AB student because I'm going to see ya.
What the heck? Who said that? You were so square.
That's right. I'm like 25. It's a square that's perfect. Great. So the square root of 25 is 5. And you said you're going to add it to the 7? I got a question for you. What's in between the 7 and the radical? So when I bring it out, I'm going to multiply it. Make me go crazy. I've got kids. You guys calm me down, just so you know that. So 7 times 5 is
25.
And then what's left inside?
2.
I think I'll pop something in my neck. Now, so you've got to simplify this, and whatever factor comes out, it's being multiplied, because this is all multiplication. It's all it
Jump
is.
from addition to subtraction back to multiplication.
Because, without warning you, oh, good grief. What if I said, put everything away and take a quiz? I didn't warn you. Woo! I'm not going to do that. If I had the square root of 8 plus the square root of 98, whoop, plus the square root of 32. See, this is why I did the last example. Now, right here, can I add these guys together?
Yes.
No, I can't.
No.
If you say we're going to add them, that means they are like radical. Hold up. I'm in the middle of talking, and I'm on my soapbox. There's not room for 2 people. You have to have like radicals. That means they all have to have the same index. Guess what? They do. They also have to have the same radicand. Guess what? They don't. Now, I know if I look at the square root of 8, I can do something with that, right? Because how does he break down?
Did you find a common denominator then?
There are no denominators here except for one. They already have a common denominator. Yippee, I'm happy. How can I break down 8?
4 and 2.
I can break that down as 4 times 2. I don't want a common denominator. But if I can get these guys to have the same radicand, then some it's got to, you know what I'm saying. You know.
Okay, let's do the second.
So what's the square root of 4?
2.
So what does this first term become?
2.
2 square roots of
2.
2 plus. Now, I want you to think about this. If I had a 2 left over here, it would sure be nice if I had what factors left over here for these guys?
2.
I had 2, which would make them like radicals. So does 2 go into 98? How many times? 49. Oh, dog, look at that.
Oh, geez.
7 and 2.
So this guy comes out as a 7, so this guy becomes 7 with a house of 2. Or 7 square roots of 2 if we're going to be, if we're not nasty. 32.
16.
16 and 2. Oh, it just keeps getting better.
It has 4.
The square root of 16 is 4. So I have what?
So you have 7, 11, 12, 13.
I have 4 square roots of 2, right? How much square root of 2 do I have?
13 square roots of 2.
I get 13 square roots of 2.
That's not that bad.
That's
Get big numbers.
oh, it really isn't that bad.
To you.
There you go again, think it fast.
Yeah, there I go thinking for you, thinking that you guys can
Take
do.
the test for me too.
and
Okay.
take the test for you,
Yes, you do.
girl. You are outside your mind.
I'm inside partially.
All right. So let me try something else for you. Let's try another one. Okay. So this was a good example. If I do the square root of 90 plus 3 square roots of 160. Yeah, I've ruined everything for you. Give up now. Do I have like radicals?
You don't have these things.
No. Now, I do want to make sure you do write things correctly. This is 3 times the square root. This is not a cube root. Okay. How can I break down 90? Does it break down? Give me some good news here.
30 and 3.
You could do 30 times 3. I don't get any perfect squares from that.
Or
But is
9
it
times
36 and something?
I could do 9 times 10, right?
But it doesn't break down evenly then.
Wait a minute.
Oh,
9's a square, right? How would 10 break down?
5 to 2.
Does it break down in a way that can help us out at all? No, so this is my perfect square. That gives me a 3. So what does this first radical become?
3 and 10 something. How you say that again?
3 square roots of 10.
3 square roots of 10.
Does 10 go into the other radical?
Yes.
So how does this guy break down?
16 and 10.
16 times 10. Yeah.
And that'd be 4 times 3.
Right, since this is already 3 out here, so it's going to be 3 times 4, and I get what? You
I'm getting a meal class.
I get 12 square roots of 10. So then what do I have?
Equals
15 square roots of 10.
15 square roots.
I get 15 times the square root of 10. Questions about that one?
So we pull 4 out of the perfect square of 16, then you,
Yeah, the square root of 16 is 4, and it's not just going to go in front of the radical because there was a 3 already here. So you have to multiply that because it's all multiplication, and that's how we got the 12.